Yes, it's lesson 5.3, solving equations, with help from Yoda and help from Luke and some others, as you will see as we progress through the video. So before we begin, we want to hear some words of advice from Yoda.
Strong am I with the Force.
Well, he is strong with the Force, but strong you will be with solving equations when we are done with this unit. So let's start with something that we know. Let's remember from 5.1 the definition of an equation. Okay? An equation is a complete mathematical sentence with an equal sign and an answer. We are trying to find a value for the variable to make the equation true. So these are three examples of different equations. Notice they all have equal sign. They have something on either side of the equal sign. And where our goal is to figure out what value for x will make that sentence true. There's sometimes one value. Most of the time there's one value for x that makes that true. Let's think about it in the first instance. X plus 6 equals 20. Well, hopefully that was pretty easy for you to think through and say, oh, of course, x equals 14. But what math did you actually do to get that? How did you get 14? Well, you have to think about this for a minute. Actually, you subtracted 6. You subtracted 6 from 20. But in an equation, you need to show it on both sides, because if we have something that's equal, to keep it in balance, you have to do the same thing on both sides of the equation. So if I draw a line here, 6 minus 6 is 0, leaving me only with an x on this side. 20 minus 6 is 14, which gives me the answer. I know you didn't really need to do that process to get the answer, but you're going to be learning the process officially in the coming pages of this video. Okay, 2 times x equals 60. Well, let's think about that. 2 times what number gives me 60? X should equal 30, because 2 times 30 is 60. What math did you do to get that? Well, actually, you divided both sides of this equation by 2. Kept it in balance, did the same thing on both sides. 2 divided by 2 is equivalent to 1, so that gives me x by itself, or 1x. 6 divided by 2 gives me 30, and I get the value of my equation. Okay, can you think through the next one? 4 times x plus 1 equals 21. What value will make that true? Well, hopefully you could think through it and say, well, x equals 5. And how did I do that? Well, first you should have taken 1 away from 21 and gotten 20. Which actually you would have really had to do minus 1 on this side as well, which 1 minus 1 would cancel out because it's just 0. And then I have 4x equals 20. And you'd say, well, I split 20 into 4 equal parts, and that's what gave me 5. Well, you might be saying, hold on a minute, I didn't actually do all that. Or maybe I did, but I wasn't really aware of doing it all. Hopefully you'll be aware of it in the next few steps. But if I put a value of 5 in here, I would have 4 times 5 is 20, plus 1 equals 21, which would work out perfectly. Okay, let's move on. Next page, we're going to look at Chewbacca giving us some advice, and he's saying equations can be looked at like pan balances. So let's see how Chewie would say that. That's right. It may sound painful, but that's actually his excitement. Let's listen to it one more time. Thanks, Chewie. Okay, so if we're looking at equations as pan balances, basically we're saying that we want this balance, a pan balance. I didn't actually know that word, but I think of just the word balance. This is equal. This is the fulcrum. And if it's equal, then both sides have to be perfectly balanced. And at the present moment, they are not. So actually, I should have erased that. What the heck? There we go. Until it is perfectly balanced. But right now, in order to make it balanced, I'm going to need to add a blue piece. Okay, so now I have 2 blue pieces on both sides, and it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 yellow pieces on both sides. So that would mean it's perfectly in balance. Now notice, if I take away one blue one on the left-hand side, it's out of balance. So in order to keep something in balance or equals in math, I need to do the same thing to both sides. So if I take a blue one away on the right-hand side, now it's perfectly balanced out. If I add a yellow one, or if let's take away 2 yellow ones on the left side, I have to take 2 away on the right side to keep it balanced. Okay, so that's the general premise of solving an equation. We want to always keep it balanced if it started out equals. Okay, if I add a yellow one here, I need to add a yellow one here, etc. Okay, thanks, Chewy. We're gonna take this and we're gonna extend it as far as we can. Okay, oh, we've got some more friends here to help us. C3PO and R2D2. What sort of things might they have to say? Well, thank you, R2D2. Didn't sound like C3PO had much to say, but usually he does. So we'll probably find something from him later. But at this point, we're going to take a look at this being our pan balance. And the first equation we're going to look at is one that you're going to find in your book in the lesson later. Okay, so let me get my pen. The first one I'm going to look at is going to have, okay, it's like a money bag, and you don't know how many coins are in it, but basically it's an unknown amount of coins are in that bag and in this bag. Those are really terrible. Let me see if I can get some new ones. Let's do some new ones because those are really kind of messy looking. Okay, I think in the book they actually do squares, so let's try that. If you could call that a square. Okay, so 2 squares have unknown amount of coins in them, or 2 bags have unknown amount of coins in them, and then there's 4 coins that are known, and that's going to be on the left-hand side. And on the right-hand side, I'm going to have 14 coins. Okay, and I'm telling you in the beginning of this problem that this balance is perfectly balanced. Meaning it's equal, so both sides are equal. And my goal is to figure out, well, how many coins are there inside of those squares? What is that equivalent to? So if I have 4 coins on this side, I can actually cross those 4 coins out. But if I cross the 4 coins out, I have to keep it balanced and cross out 4 coins on the right-hand side. And once I do it on both sides, my balance stays perfectly equal or in balance. Now I've got 2 unknown amounts in here, and I've got left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 coins. So if I were to split my 10 coins into 2 groups, I would have 5 in each group. So that means there's 5 coins here and 5 coins here. And let's see if that works out. I've got 5 plus 5 is 10, 11, 12, 13, 14. So that means I've got 14 coins on this side. And over here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 coins over here. And that's where I started. And I started with 14 and 14, and at the very end I found out, well, in one bag was 5 coins, which made this equation true. Okay, well, great. I love the picture, but how does it look like in algebra? Well, the unknown was how many was in the box. So I had 2 of those boxes. Let's call it 2x. And then I had 4 coins. So 2x plus 4 more coins equaled 14 coins on this side. Then the first thing I did was I crossed out 4 coins. And I crossed out 4 coins. So what is that like in math? Subtract 4 on both sides of the equation. Okay, what does that leave me with? Well, the 4 went away, and I had 2 money bags left, or 2x. And on this side, I had 14 take away 4, or I had 10 coins left. Then I split my bags into 2 different bags, so I split it into 2 bags. And I split my 10 coins into 2 groups, which made it x, or 1 bag, equals 5. And that's how I solve my equation using algebra. Let's try another one. I'm going to need some more room down here. Okay, so in this one, I want to do it first visually, and then I'm going to do it using algebra. Okay, so I've got, on this side, let's say I've got 10 coins, and on this side I've got 3 bags and 1 coin. Okay, so now if I'm going to start canceling things out, I'm first going to say, all right, in order to get my money bags by themselves so I can see what's going on, I'm going to cross out 1 coin on both sides, which leaves me 3 bags on this side and 9 coins on this side. Then I'm going to split this into 3 equal groups. Here's 1, 2, 3 equal groups, and I'm going to split this into 3 equal groups. Oh, well, that works out nicely, doesn't it? In each money bag, or unknown, is 3 coins. Let's try it. 3, 6, 9, 10 on this side, and on this side I had 10 coins, so it works out perfectly. Okay, what does the algebra look like? I had 10, the fulcrum means equals 3x plus 1. First I took away 1 coin on both sides, which gave me 3x left on this side because the 1's canceled. And on this side, 10 minus 1, or 9 coins. Then I divided it into 3 equal groups and divided it into 3 equal groups. And I got x equals 3 coins per bag. And I checked my answer, and it indeed worked. Okay, let's go on to the next page and see what we've got here. We've got some more, but I think it's time for us to move on to Obi-Wan and Darth Vader. So, what words of wisdom might they have to say? Well, Darth Vader will tell you this. Ready?
You don't know the power of the dark side.
You don't know the power of the dark side, and that's why Obi-Wan is going to tell us that we need to really know how to do this equation so that we can overcome the dark side of the Force. All right, so here I've got 2 equations that don't have pan balances. The first thing I want you to think about is, here's my fulcrum. So I encourage people to draw a line here so they know that's the middle of their equation. And they've got 5 money bags plus 7 coins is equal to 32 coins. First thing I want to do is I want to subtract 7 coins on both sides because I want to just have the money bags by themselves. 7 minus 7 cancels and goes away. 32 minus 7 will give me 25 coins. On this side, I still have my 5 money bags, and my equals is in the same place. Then I want to split my 5 money bags into 5 groups. I want to split my 25 coins into 5 groups, and I get x equals 5 coins in each bag. So let's check it. Let's check it in black. 5 was in the equation to begin with, times x, which I said was 5 right here. So 5 times 5 plus 7. Well, I do that. 5 times 5 is 25 plus 7. Does that equal 32? And indeed it does. That's a check step. Okay, now let's look at a little more difficult equation, a little bit more of the dark side. We've got negatives and we've got division. What it says is negative 90 equals c divided by 2 minus 12. This one is very difficult to visualize, so we need to use our math skills to figure it out. That's the middle of my equation. I start on the side that has the variable, c, and I want to get c by itself, just like I got x by itself up here. So I have a divided by 2 and I have a subtract 12. I'm going to deal with my addition and subtraction first, like I did up here, because those are my kind of extraneous coins. So because it says minus 12, I have to do the opposite, which is plus 12 on both sides. Negative 12 or minus 12 plus 12 will go away, and I will have c divided by 2 on the right-hand side of my equation. On the left-hand side of my equation, I have negative 90 minus 12, which should give you negative 78. Okay, so now I have negative 78 equals c divided by 2. In order to get c by itself, I have to do the opposite of dividing by 2. The opposite of dividing by 2 is multiplying by 2. So I multiply this side of the equation by 2, which will cancel. And I multiply this side of the equation by 2, which will give me c on this side, equals negative times positive is negative, and 78 times 78 is 156. I had to think about that one for a minute. Okay? And then you can always go ahead and check it, and you say, okay, if I have negative 90 on this side equals negative 156 divided by 2 minus 12. So if I knew negative 156 divided by 12 in a calculator, I would get negative 78. Negative 78 minus 12 is the same as negative 78 plus negative 12, which indeed equals negative 90, so it works out. Now, this one was definitely harder. I expect that you'll do most of these types in class, but I hope the ones prior to this seem to be pretty straightforward. Good luck, and I think you have the power of the Force to get there. Let me leave you with some more Star Wars to think about.